Hi everyone, my name is Victor Fogos da Rocha, and today I'm going to present you my work, in this case the Super Resolution GAN, improving Yolo's performance benchmark, and which has been done with the help of my co-orientators as Nini Azag, Mustafa Liban, and also Anissa Mokawi. It has been supported by the Lipien Laboratory and the COS Enterprise. So this work we can resume it into some different topics. The first one is improve the performance of different versions of Yolo's object detections models. The use of super resolution generated adversarial network, an SRGAN, without increasing the size of the initial training dataset, and also we analyzed the effects of different values of scale factor values on the benchmark's results. So this work has been developed into three specific points, around three different points. The first one, 3 different points, which has been explained into three steps, and the use of one metric. The first one, step 1, was the use of the SRGAN model to generate a new image to be used in the step 2, which is the use of different object detections model, and then the analysis of this benchmarking using the frugality score metric. So some basic concepts is in the case of the SRGAN model is it's a generator, a kind of generator, which uses a smaller image and then generated a reconstructed image as good as the original one, as we can see here. In our case, it's not perfect, of course, but it has a great quality. It has some great good results. So in case of the object detection using the Yolo's model, we had chosen the Yolos because of its architecture has present some offers some better performance in relation to the traditional to the other object detection models, as the faster RCNN or the fast RCNN, faster in the fast RCNN, but true difference between. And also we had used the different metric, the frugality score metric, which estimated the use of different models into different systems, and with this we can analyze how good a model is, how good its performance is, into a system with a better CPU or with a better GPU. Only analyze this metric. So we employ a specific metric. In our case, it was the MAP, the mean average precision, and also the frame rate for the interception over union of equal 0.5. Also, we change the variable in this matrix is the frugality on the system, as here represented by W. So the SRGAN model improving the Yolo's object detection can be resumed by one pre-process, which generated different smaller image which has been used to generate an image with 2 different dimensions on the 416 and this 640, which are one of the most common dimensions in the input shapes in models on the object detections area. It's important to to observe is that it was necessary to decrease the image size of the image, the original image, to be passed for the model, in the object detection model, to make it faster to analyze and detect the objects. So with these image generations, we generated two new datasets: the generated trained dataset and the evaluation trained dataset. With this new trained generated dataset, the generated trained dataset, I'm sorry, we train all the models, and then we did the cross validation between the generated evaluation dataset and the original trained dataset, evaluation dataset, and then we compared the results. So it was a great challenge for us using in our work, because the almost 60% of the object has they were smaller than, they had a size between 10 and 50 pixels, which was necessary to apply some transformations and employ the data augmentation method. Some transformation as the rotation, the horizontal flip, the change in the scale value, and all the other ones. So in relation to a dataset, we had used the DOTA dataset, which contains almost 2,800 images into 16 classes, as the smaller vehicle, large vehicle, baseball diamond, ground field track, and others. We had used the version 1.5. It's also important to describe. So some of our hyperparameters was we had researched the better parameters, and the best one was for the 16 for the batch size of 16 image, a maximum of 100 epochs. We did it as a default for all the models. We got a frame rate equals to 5a negative 4. We had used the ADA optimizer, and as the loss function, we had used the focal loss because of our unbalanced dataset. So to evaluate the SRGAN model, we had used it has been selected 3 different metrics: the SSAN to analyze the symmetry between the original image and the generated one, the MSA, the mean squared error, to analyze the error between the intensity, the pixel intensity value, and the PSNR, peak signal to noise ratio, to analyze the noise in this generated image, and see how good, and with these 3 matrix, analyze how good the generated image is or it's not in relation to the original one, the expected image. In relation to the evaluation metrics, to evaluate the object detections model, we had used some matrix as the matrix precision, recall, and mean average precision for 0.5, and also for 0.5 and between 0.5 and 0.95. I'm sorry. Also, we had analyzed the frame rate to see how fast the system is to process these images. Sorry, the number of parameters to also has the idea of the model's size in relation to the quality of this response, these answers. And the flops, the quantity of is a calculation metric of our system. So we had also used a cluster, which has been clustered off the Université from the Université Paris 13, and it was which has supported in the technical support with the equipments as a computer of Intel in the cluster, 124 gigabytes of RAM, and a GPU with 16 gigabytes of VRAM, and also 100 gigabytes of memory to be used in all this work. So, in relation to some results in the performance in our performance analysis, as we can see here, for different values of the higher resolution, we can see that for the greater compression or greater reconstruction, we lost the object information. So when we started to take a greater compression and then making a reconstruction, we lost considerable the object's information in relation to its format. As we can see here, when the scale factor is equal 4, it starts to we can see that it started to have a fusion between the objects. This is expected from the original image, and for a scale factor equals to 4, 5. So to analyze the benchmarks, the object detection performance in the benchmarks, we divided three different. We had prepared. Three different scenarios. The scenario one, the original, the use of the original trained dataset with the original evaluation trained dataset. The second one is using the generated trained dataset and the original evaluation dataset. And the third one is the use of the generated dataset and also the generated evaluation dataset. And then we did its validation. So in relation to strategy 1, we got the results in relation to the greater resolution. We can observe that for a scale factor equals to 2, we got a better result, but in this case we have a limitation to its increasing until the 4. So if we have a greater compression, we can observe it that started from the S scale factor equals 4, we started to have a worst result. In relation to all the scenarios 2 and 3 performance were compared to scenario 1. So in this case, for scenario 1, we had a increase of 0, of course, because we had comparing him with himself. it with itself. And in relation to the scenario 2, for the lowest resolution in this case for this table, we got a better result for the scenario 2. So using the training dataset, the generated training dataset, and the original one, so we observed almost 1% of the decrease of our recall. In relation to a greater resolution, as we can see here, we see the scenario of a better increase in the scenario 2 for the mean average behavior, of 1.72. However, we can observe a better increase in its value, a better improvement in its metrics values in relation to the scenario 3 with the generation and the cross-validation one. So in this case, in relation to the I almost forgot, in relation to the frugality scoring metric, we observed that a discrete decrease of almost 0.80% reference to the scenario 1, and also almost the same decrease in relation to the scenario 3. So we had a decrease of 0.81. Okay, in relation to all the matrix is to the lowest resolution, we got a better result in general relation to the Yolo V5 transformer, which is the one of the smallest one. However, we feel one of the greatest results in all the scenarios. So with the lowest frame rate, as I'm pointing here, a not so high gigaflops from which has been demanded from the system. And when we see for the greater resolution, as we can see here, we also the same model has presented one of the lowest time to be trained, also the same size, almost the same quantity of almost the same gigaflops, and one of the lowest frame rates and one of the most stable, as we can see here, in relation to all of our 10 models. So in conclusions, we presented this work presented a benchmark using only the Yolo's models architecture, included one of the last versions, the Yolo 5, represents of the influence of different scale factor values for the SRGAN usage, the impact of the mean performance when using the SRGAN by different values, estimated the model's performance into different systems using the frugality score matrix, and also in the end we have seen that the Yolo's transformer, which has used the block of transformation, has presented the best result. Some of our reference, and also one annex that I wanted to show you the quality of the SRGAN. So for the scale factor equals 4, we had one of the greatest quality generated model in relation to the other transformations. Also in relation to the symmetry, and also in relation to the error and in the noise. And this is all. Thanks so much. Have a good day.